Can you start now?
Yes, sir.
Okay, so in the previous session, we have discussed about the NumPy library, and I think we have covered that basic array operation like the broadcasting and all this possible. Now, when we talk about the machine learning application in case of the machine learning, so in the machine learning, we required a linear algebra libraries functions. Sometime So linear algebra, why we require linear algebra? Because let's say you want to process something as I said that every data you consider is just a matrix inside the number, and once you do that, you require small operations like numerical operations and all, like a matrix multiplication, derivation, and all that need a linear algebra. And another thing is the requirement is that to understand the data representation base better, it's always the linear algebra is an important tool of the mathematics which helps to understand the data better. Let's say if you consider a simple data image process image or any data, you want to know about the orientation of the data, then we always use eigenvalue decomposition or singular value decomposition. So these are the basic linear algebraic methods are there. But let's say if you want to process that by your own, doing the some kind of using the some Python operators only, like a multiplication or division or the addition or subtraction, then it requires some of the steps. And if you want to perform this kind of mathematical steps by your own without any Python library function, then it's sometimes it's a cumbersome. It's difficult for you. So the basic thing is that some library functions are available for a basic algebra operations, which is very useful. So on a screen you can see that if you define the two matrix and you want to do the dot product matrix multiplication, then you simply use the dot product and it will do the matrix multiplication operations. Um, Same way, let's say if you want to do the eigenvalue decomposition. So can anyone give me the idea what is the application of eigenvalue decomposition in data representation, or why we required eigenvalue decomposition so much in any data representation or something? So to make a sense, session little bit interactive. Uh, why we require eigenvalue decomposition, or what is the important of the eigenvalue decomposition, if anyone, or so basically eigenvalues and eigenvectors. So if you say some metrics in terms of, let's say, if I define let's say if you define some matrix or some data orientation, if you simply say that, let's say this is the data matrix, or this is the data 2D data, let's say we consider about the R2 data. In R2 data, let's say if your data points are varying in this, so it may require a two dimension, but we know that its eigenvalue, its characteristics are in this direction. So if I say that the direction of this data is like this, so if you able to represent the characteristic direction, that is important. So eigenvalue itself is the importance about importance or the characteristics of the data. So where the data is varying too much, that you can directly get the eigenvalue. So the matrix transformation basically is nothing but it's just a you have a data in some R2 domain, and if you want to go in another domain, you simply apply the matrix transformation and you can go with the so basically, let's say if you talk about the R2, in R2 you require a 2D vector, let's say x and y, to represent any point. And if you want to go from one R2 to another, let's say R dash 2, so you require some kind of matrix which having a 2 cross 2 dimension, so which will transform here from here. So there are some techniques of data representation like a principal component analysis and all, where you use this eigenvalue decomposition, and then you find out the data orientation and you shift the direction of your basis where the data is actually varying, and that helps a lot in terms of understanding the data better. So sometime what you have that let's say if you have a square value, then you will get the eigenvalue decomposition, uh, eigenvalue decomposition of the square matrix. And so in an eigenvalue decomposition, you get the eigenvalue. So what eigenvalue means? Eigenvalue gives the magnitude of the variation, and eigenvector gives the direction of the variation. So as I just given the example that if let's say this is the case, So this is the case. The data points are like this, so that this data is varying in this. So its magnitude, you can say that is in this direction. Its magnitude is depends on variation. So, but this direction, let's say the one direction, then you can say that is by the eigenvector, and the eigenvalues are representing the variation in that direction. So so that is the case. But what if we have your data is not a square? So in that case, we go with the singular value decomposition. We can have a whole linear algebraic session, or you can always refer the singular value decomposition, a very important tool in image processing, signal processing, and all the way where you can diagonalize the non-possible non-square matrix, and it will give you idea. So you can use the simple SVD for image compression and all the applications. If you're interested and if someone have a doubt, I can give some idea about how to use the SVD on image processing. Otherwise, we can see just uh, the whatever libraries we have, and we conclude this session. So this is about the linear algebra. There are so many linear algebra tools like a PCA, and let's say you want to find out the covariance of the data, and all that's are available in this linear algebra toolbox. So actually, linear algebra is a sub library of the NumPy library. So how you can access? You simply require linear algebra. This is a library name, linear LINALG, and use the function of this. So the LINALG is a sub library of the NumPy, and you use the function eigenvalue. So that's the case with the NumPy. Sort of an introduction about the NumPy, but now we talk about the how we use the NumPy in a machine learning extensively, because as I said that most of the data processing initially, when the data comes to you as an image and video, when you take a data you reading the data, ultimately it's a matrix. It's either let's say if you take a audio signal and it's an array, let's say it's an image, then it's a 2D array. If it's a video, then it's a 3-dimensional array, because there is x and y spatial and as well as the time domain. So then in these cases, you require the data manipulations and all in times of matrix multiplication. So you can always use the NumPy libraries are there. But NumPy library is just providing a matrix operation which are not sufficient for performing the machine learning process. But if you want to do the machine learning applications, you can do the using a NumPy, but you need to uh, perform computation by your own for each step. Let's say that gradient calculation and all, you need to do that gradient calculation, and you want to you need to use so many for loops and all that algorithms you need to write by your own source. So all the machine learning algorithms you can develop using a NumPy. Like all the machine learning applications you can algorithms you can develop using MATLAB, like you can do with the NumPy. But why when we are working in a applied domain of the machine learning, where we are not contributing something in the machine learning, we just want to use the machine learning as a tool in our research. We do not rely that how to do the gradient descent, let's say how to do support vector machine, how to do the PCA or any machine learning technique. I just want to use that as a tool. Then there are a library called sklearn library and other machine learning libraries, which is very useful, and just one line functions are there to do that. So yeah, so 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 there are the libraries are there. But again, then the question comes that that's the only way. No, we have so many other way to read the data. One of the libraries is called Panda library basically depends on the tables. So when we see the data, you can see that data is a matrix, and you can go with the NumPy. But let's say if your data is, if you are seeing the data is in terms of tables, and which is mostly the case when we are doing the data science projects like NLP, or you do some house prediction analysis or simple machine learning applications, you always comes across with the Excel files or CSV files. Then you use the pandas, which is very much good, very much compared to the NumPy library. The Panda will be give you very much data analysis. So the Panda is again open source library, is again the Python based library built on the top of NumPy. So it's have all the mathematical operations like a NumPy, and Python's basic operations are there, but it is basically made for the machine learning community and data science community. It is used for very much of that. It's a powerful handling a structured tabular data, as I say. Data pre-processing capabilities are very good in pandas. Why data processing capability? Let's say if your data sets having some data which is not appropriate, let's say in your one of the features having some bad values or something, some outliers are there, you can easily mitigate that using pandas libraries and all, like a nan value and all that you can easily do. Okay. So in a day, what is the key data structure of the Panda is the series and data frame and all. Let's see some in this. So again, if you want, if your library is not installed, you can directly install like this. PP install is, you can include the Panda there like this. Now series is kind of Panda array. You can define the series like this. So you see here, when we define the Panda series, is actually by default providing the indexing as well as this data type, appropriate data type. So left first column will be defining the index and second column will define the value. So automatically it's kind of the dictionary, key and value. But let's say if you want to define the key or indexes based on your choice. Let's say you want to give some names. You do not want to use the 0, 1, 2. Then also you can provide by the index naming and data. So the keyword index and data is used, and you can always look at. Similarly, you can have a access. Now let's say if you define using a key without key, so you can access directly by the index number. But if you define it the index name with some string or something, you can always access by like the A is ABC. So what's the value of ABC? You can get it here. You can rearrange the values like this. You can directly define without this prefix like a data and index. You can do the like this, and same way you can do in a 32-bit integer. Here is saying numpy array. Let's say if you have a numpy array and itself you want to consider, then also it's possible. You can have a dictionary. Let's say dictionary is a kind of, I just said that Panda series is a kind of a dictionary. But so let's say if you already have a dictionary and if you want to define as a Panda series, you can do that also. And the beauty of with the Panda library is because Panda library is built on the NumPy, so the basic underlying functions of the NumPy and Pythons are already there. And then you can use the Panda data structure to define the elements of the data structure as a function itself also. So what I mean to say is that if you can define the Panda series which have elements like a functions. So you can see here the A is just an array, but B is a Panda series, and the element of Panda series is sum, mean, and max, which is actually a function. It is not a string, not a values, or not an integer. It's actually a function. So when you and let's say you want to apply the function, so kind of you can also create the data structure which having all the type of inbuilt function, and you want to use that as a operator, you can do that. So here you see B0. So obviously B0 representing a sum. So sum. So when you access the B0, what it's going to give you? It's giving you sum. Now sum itself is a function. So function requires the argument. Here we given the argument is the A array, so automatically it will do the summation. Same way, 1 will do the minimum and 2 will be do the maximum. Okay. There are certain things like this. You can have a Panda dictionary there, but in case of the dictionary, when you are going to perform, let's say A plus B or something, it is going to give you error because dictionary does not have the functionality to match the index and perform the operation. But when I do the same with the Panda series, I'm able to do that. So what's the difference here? In a dictionary, know that there are in a dictionary, let's say here A, B, and C and D, four key values are there, and each have a representative value 5, 3, 10, and 20. And A is also key here like this. But they unsupported operator plus. Dictionary does not support the arithmetic operator. But Panda is built on because dictionary is directly built on dictionary is the data structure of Python. Got it? But Panda is built on the NumPy. NumPy is also built on the Python. So Panda itself support the numbering also. Panda also support the same type of functionality as the NumPy. So when you see here the PD series A, PD series B, automatically they can do like a that like NumPy array addition. If you have a NumPy array A and NumPy array B, you can do always the addition of the two arrays. But here, if you want to do the key wise, because array having a default index like a 0 add with the 0 index, 1 add with the 1 index, 2 add with the 2 index, 3 add with the 3 index, like that. But let's say if you are dictionary kind of thing and you are providing a features name of key values, you want to add the key value by value. So you can see here, so A, B, C is matching, so they add it, but D is not present in D, so it's giving you a none error. Okay. So other functionality, again, you can explore so many operators here. I used to given these links, which you please explore this. At least after this talk is over, you just explore this, you do and try it by yourself, you will get the benefit of it. And when you are going to use it, you should not stuck with the NumPy, you go with the Panda and all, you can also work. Now the second type of data set is the data frame. So the data frame is kind of that there's a two thing, data having a two dimensional data. So like a data frame in a series, you can consider like array. In a data frame, it is considered like a matrix, but it's having a two type of index. One is representing columns, and another representing index. Column is a different, index is a different. So column representing a column name, and index representing a, by default, if you don't provide any indexing name, it's going to take a 0, 1 and 2 or like that. But if you want to provide the index name, you can provide like this, that x1, x2, x3. So automatically it will take the x1, x2, x3. But here in the first example, I given a name to the column, but I did not give the index name. So it will take the name to the column, but not to the index. In a second case, you take a name to the index, but not the column, then it's also possible. And you can do the both. So there is a very huge advantage of this data frame structure, because in a data frame structure, you can represent any complex data in a tabular form. So in a tabular form, what we have in a rows, we have column, we have a merge rows and merge columns. Means some are subcategories, category, subcategory, subcategory, like this in a row and column wise. So you can always do this using a data frame. So I'm just giving some example here. And also you can access via the indexing. So here we define the A. So if you want to access the column, you simply write AY1 or A.Y1, you will get the idea. If you want to do the indexing side, or you want to do from the index point of view. So mostly what data frames refer to, the data frame, we mostly refer in a machine learning community, we refer the columns as a features. So if your data set, let's say most of the machine learning application, if someone let's say, I will just give the basic example of the house price prediction. Now house have a different features. Let's say square meter of the area. So house area is the one feature. How many numbers of bedrooms, there is another feature. So these are numbers of features are there. House area, numbers of bedrooms, and let's say is a location, and these are the features. So you can that's a column, and the price is also one feature. So you can say, or you can say output. So based on the given the data, let's say if you want to predict the price of the house, then these features will be the columns. So the numbers of bedroom and this all becomes the column. And in your data set, there are thousands of house of data is there. So then each data is represented samples. So samples is represented by the indexing, and the columns representing feature. So you can say, let's say if you want to do the particular sample, then you can give the set sample name, and you can always do that. You can always do the iLoc. What iLoc give? iLoc give the location of the, so x1 is giving you the values of y1, y2, y3 for each feature. If you use the iLocation, then it's actually giving you y1, y2, y3 0. This is a similar kind of thing. So what it is for a zeroth index. So here x1 is the index name, and here is the x1 0 is representing which index you are referring to. So if I am referring to zeroth index, if I want to see the one, then I simply take the one. And sorry. And it will give you the second row. You see. So likewise, you can perform, and we can teach you very much of anything you can think. You can have what's the value of x1, y1, what's the value of y1, 1, 1. Let's say if you want to have a sub data frame from the data frame, then also you can take same way. Okay, you can add, let's say now you want to create a new feature. So this is now not available in NumPy. Let's say I have features, but I want to, I know that this is the summation of this, or I can get it from this. So here y1, y2, y3, I just directly want the summation. If I go with the for loop, then it's require so many iterations. But if I have a data set panda library, then I simply take the a1, y1 and a sum. And in that also I define simply a as a sum. Automatically it will add the one feature and make it as a its own new feature. You can drop one of the feature. Yes, obviously. You can drop a row. That's also possible. So many things you possible. You can directly process the if-else condition. You do not require go to element by element. You can have some called conditional operators, and after doing the condition operator, you want to use that as indices. Yes, you can do that. So many things you can do. You explore it by, means it's kind of fun game. You can explore these things. And you can also reset the index. Earlier index name is given is a 11123. So you can always reset the index and get the new index. So previous index has become like this, and view this. Then you want, say, let's say I want to represent my index with the sum or my any of the column. I can make it as a index. So that become my index. So setting index and all in place of true. Everything is possible from this. Now, multi-index, as I said, that in a tabular data, what's mostly we have? We have category, subcategory, like the structure of this. Let's say you have first category. In that, there is a subcategory, and in that, there is a third category. So you see here 1 1 1 1 representing 2 2 representing. So from that 1 1, there is another category. You can define this kind of indexing, multi-indexing, and then you use that multi-index array to define this data. So you can see simply there's first category, in second category, third category, and it's a features also there. And then you can again do the same operator. But what is going to happen? The first will be representing first category. So one you see here is representing this part. When if I to take a 2, then it is going to represent the below column. If I want to access this part, then you need to use location 1, location 2, or location 1 like this. So many operations you can do. First, second, third, you can give the name to index. That's also possible. So this is about the data frame. Data frame is very useful. And let's say if some of you are working with some kind of data science problems, you may come across the data frames. Now the question comes when we are taking, let's say you are doing some kind of some sensor readings are there, okay, and you want to do some IoT application, okay. In IoT application, what we from the edge devices we getting a reading, we continuously reading, and based on that reading, we may get some prediction. Based on that, we can have some smart algorithm which will make a decision. So we can use a machine learning very well in IoT. But what happens that sensor will not give every time the correct value, or what we say sensor sometimes maybe sometime due to some glitch or some problem at the sensor side or some overheating, or sometime at particular instant. Let's say every 5 minutes you taking a reading, but at some instant you may not able to get the reading, and you do not have value for that particular value. You are having a smart system which is relying on the multiple smart sensors. Each sensor can provide as a one feature value, but some sensors may not give the one of the sensor is held to provide the value at some time. So then data should be there, but do you want to process? But if data is not there, then you cannot process. So that's why the cleaning of the data is required. Doing the machine learning, cleaning of the data means data non-availability, data having infinite. You have infinite data, that's also problem. So let's say if you define some data frame and you want a data cleaning. So here, let's say first of all, I create a name value. By creating any greater than value -1 value, that's only I consider as a C data frame. So the value which are less than -1, I am not considered in this. So automatically become the name. If I simply write a drop NA, automatically the samples which is having a name value automatically neglected. What happens in most of the time machine learning, when you are doing a algorithm or when you are implementing algorithm, you always stuck with a nan error. So if you have this panda library in use, then it's very easy to dropping a nan value or finding out the infinite value. And again you can change deliberately, you can change the some locations values or you can do that. Let's say infinite values are there, you can replace the infinite values with the none value, and then again you none. So after performing some arithmetic operation, what is going to happen? You do not know. Let's say your sensor is off and it's giving just 0 value, and after some arithmetic operation is giving infinite value, and then you cannot proceed further. Then simply convert the infinite value to none and you can drop it. So there's all the data cleaning processes. There are so many. There is a topic called EDA, explanatory data analysis. You can perform that before the data, and you can always get your data clean, and for that you can go. So that is about the data filling and meaning and just. And data loading and inception, that's also possible directly. You can use the CSV file as a data frame. You can see here panda read CSV file. So this is about reading a data, handling missing data, aggregation, grouping, data indentation. These all things you can do very well in a case of the panda. So here you see group by students. So this is the data comes from this CSV file. After that, if you want to group the students wise, so what is going to happen? Students index values are matching, and everything automatically it will combine the data. So the data itself is going to be combined by the student category. So when you simply take the describe is a very useful function. Whenever you find any new data, you take a simply data as a data frame. After taking a data frame as a panda, you simply describe, it will give you the whole idea about data. So here B is a group by the student. So actually B is going to be grouped by the student 1. So student 1, everything is going to be grouped. Student 2 is everything is going to be grouped, and student 3 is always going to be grouped. And after that, if you describe, then B will look like this. Student 1 having a maximum count of 3. So there is a student 1 3 times, student 2 3 times, student 3 times, and what's the mean value of the its marks, and everything is you getting is here. You can also get grab by the subjects. You see your subjects are there possible. Grab by the grade. It means whatever get data is like this. You have a multiple data and you want to do the data analysis for different features. You can do this very easily. You can concate the data very easily. There are so many data operations you can perform here. So two data frame. If you want to concate in a row wise, you can concate. If you want to do the column wise, you can do concate. You can merge the data. Your two data you have. You want to merge it. You can merge it. Okay, you can reset index and all the possibilities are there. Join is also possible where so actually if I say for a data structure point of view, you can get the idea about everything before this also if you do not know the panda. But let's say if you are introduced to DBMS, base management system. So basically this is a computer science concept, computer science core area. So DBMS is handling how to handle tabular data very well, and most of the data available in the tables. So in that, the most important is how to use the attributes, and using the attribute, how to store the data, how to recall the data, key query, and everything is comes in that. So if you want to do this kind of DBMS things, also so many things, DBMS operation, outer join, inner join, this can be done using a simple this panda functions like this join, which is a DBMS function there. By indexing, you want to join, you can join it like this. You can also perform the operations like read CSV. So this is just example of the one Olympic CSV. I think it's a 21 Olympic data or previous Olympic data, and I'm just having a head will represent the 5 column. What are the unique values you can represent? Not unique values, count values. We want to find out the gold category mean, how many golds, what is the mean everybody gets the 3.5. How which country having a gold is equal to silver, gold is equal to bronze. I'm little bit going to just because it's just you can go through it and you will get the idea. If you have any doubts, you can pose me. Otherwise, I will come go ahead. So these are the functions which you can access in a pandas. Now this is about the what. So in a machine learning, first thing is required is that you all need to operate the NumPy numbers. So we use the NumPy library. Now you have a data in terms of tabular, and you want a data with database operations, and also it's called data cleaning, data processing part. You can do that also. Now after that, the next part comes is a data visualization. So how the data is actually there. So you need to visualize and you need to judge that data is these are the how it's the actual data look, and based on the visualization we always decide what to do that. Like we know that data visualization is oriented in some other direction. We first apply the principal component analysis and then we do the other process operations. So therefore that there are the starting library is a matplotlib library. In data visualization we do not have a limitation. There are so many libraries are present in for a data visualization. Matplotlib is just a basic example. Very popular. It's just kind of MATLAB plot functions. Okay, it's a powerful toolkit, and you can see here it's integrated with seamless with the Panda again. So it's very useful. Plots are possible. It can generate plot for the data frame and all. So let's see a little bit about the matplotlib. So matplotlib, let's say a sine wave, you can simply xlib. So it's kind of MATLAB functions. You can always plot it and all. If you find it difficult, if you want to understand, you can just pose me and give me. I think okay. Z is equal to numpy cos x and all. Like this, also in a the beauty of the Python is that you can always have an inline function. So you can see here. So let's say I just want to see the two functions at in a single line. I do not require to create a whole new function and squaring and cubing. I simply take the operation here and I can do it. Means in an element you can have a function. That's the liberty. Legend will show. So that's okay. Now the biggest thing is that data distribution. To understand data distribution is very difficult because the data distribution just try out sometime. If you just histogram plotting requires some efforts. So if you want to go to the histogram plotting is required, you need to go for each samples and then you need to define beans. So it's a little bit coding is required, and that is a cumbersome, and defining how many numbers of beans are required and all that is a very difficult part. So for any data which is a random, if you just want to see the how data is varying, the first thing comes in the mind that you just plot a histogram or see the distribution of the data. That's easy. But when you want to do that with your by hand code or by your own, it's a difficult. But there are functions in MATLAB, so you can directly histogram. So here you see we define the normal distribution of the 1,000 samples with the 0 mean 1 variance, and you can see the when you have use the histogram function, it will show like this. There are various way you can have a different axis like a subplot and all is possible. Plotting on plotting is possible. Okay. Then another library is called a Seaborn library. So this is a just basic library, but Seaborn is a very much advanced library. Seaborn is a very much advanced library in the sense that let's say I just given the example that house price have so many things, right? So how many numbers of bedrooms are there, what is the square foot size, what is the master bedroom size, numbers of bathrooms, numbers of kitchen, these are the features for a house price. Okay, so when you are predicting the house price, these are the features are there, but how these features, some features may be irrelevant in the sense, let's say is there numbers of kitchen, always mostly is the one, so it is irrelevant feature, let's say, but that the data in the data is already there. So how to find this irrelevant feature? And let's say this is just an example of the house price, but when you take a real-time data, there are thousands of features you have. It's not like a 4 or 5 features, and some features are directly varying with the other features. So let's say if I'm defining the numbers of bedroom have a highly correlated with the square foot area of the house. So we may not require sometime if we have a average, if you are talking about the average bedroom size is fixed, we do not need to take the square foot area, because square foot area, whatever square foot area give you as a means in for to understand the problem is automatically available by the house, so numbers of bedroom. So that one feature is depends on the second. Features cannot be independent. Okay, some features are dependent. Let's say 1,000 features we have, and we just to process the 1,000 features is very difficult. But let's say if you find out that out of 1,000 features, 600 features are independent on each other. So you simply take one significant features and make it a 5 across one or a 4 across one, where the one feature is significant you took and others you just neglect. That's also possible. So how to identifying that or how to do this EDA is very much important, and this is a very much being done by the Seaborn library. Seaborn library is also based on the matplotlib. So you can see here Python, Abo, NumPy, then data frame. So every library is built up on the other library. That's the beauty of the Python also. So Seaborn offers so many type of visualization. I will show some of the visualization here. So here the data is given by the Seaborn data set. The tips given to the restaurant. So sex, smoker, day, time. This is just a data set representing the tips given to the data, and so you can directly have a SNS is a Seaborn include. You can directly have the plotting. You can have a scatter plot, distribution plot. You have a joint plot. So here's the joint plot. What it will give for the two features, it's also give the scatter plot and as well as the distribution. Both you get in a joint plot. There are different functionality. Okay, you can always try out a different how to you want to visualize. This is very much important. Pair plot. Pair plot is very much important because it gives the feature across feature. So let's here's the three features: total bill, tip, and size. Here total bill, tip, and size. So how this total bill varying with the size, how this total bill varying with the tip, and how total bill varying is total bill is going to give you a distribution of total bill. So automatically you get the idea that okay, these features are interdependent or dependent, so you can neglect one of that. So it's give very beautiful idea, and sometimes you will find out that some features are not sharing anything, and you can always neglect. Okay, so this is the again Olympic data, and on that also pair plot is plotting. There are some pair plot using a column worm and different possibility bar plot. So whatever you do in Excels for data analysis, you can do directly with the Python libraries like the box plots, this violin plot. So these are very much important because this is giving you box plot is very much important. 25% right and 75%. So maybe some of you are interested in the stock market. We always look at the candle chart. There's nothing but this box plots are. You can always have a heat map for the correlation. Correlation is very much important. It's by large give you the gist about the data that which features are dependent on which, and automatically you get this. So these are the examples to be. So this is a cluster map which will provide that these features are collaboration with this and all. Okay. So this is again the basic data visualization part. Data visualization is based on Seaborn, and then you can do the visualization, relation, and so on. So we have seen that what's the introduction to Python, then the NumPy, which is a must necessary to just handle the data. Then we see the Panda, which exists for a data processing part. After the data processing and data cleaning. After doing the data processing and data cleaning, what's the next step? Data visualization, which we can do for the Seaborn. I'm just giving the one basic library. You can find out the ton of libraries online. Okay. Now you already did the data cleaning, data processing, and data visualization. Now you want to apply the machine learning, and you do not know the machine learning algorithms. You maybe know the name, that these are the classification algorithms are present, or these are the clustering algorithm, but you do not know the you do not want to implement it because you use the ML as a tool. You are not actually doing something in ML. So there are libraries. So sklearn is a very much important. Is the scikit-learn library. So scikit-learn is a powerful machine learning library in Python. It's provide a wide range of machine learning applications. It's kind of API. So you do not require to hand code this machine learning task. Common machine learning task is a supervised learning, unsupervised learning. So supervised learning means what? That you know the Y, you know the X, and you try to estimate the F. Unsupervised learning means you do not know about the labeling. So I will give the simplest example of supervised learning. Let's say you want to do the house price prediction. Uh, 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 you want to do the house price prediction. You have a data set with all the numbers of bedrooms and square foot area, size of the features, and along with that you have a price. You have a huge 1,000 samples, and you want to learn that. And that's a supervised learning. So how these numbers of bedroom and square foot area is depends on the price of the house. Once you learn, you can always use that theta. So it's actually supervised learning is what? Supervised learning is simply supervised learning is that y is equal to theta transpose x. You know the y, you know the x, you estimate the theta. So this is the question mark which you do the supervised learning. Okay. So given let's say this is a data set is given a x is varying like this. This is a y where the y is equal to fx. Okay. So you will find out this function. Maybe it's varying like this or something. So if I give the new point, which y is unknown, let's say I given the new point here. So what will be the value of y? If you know the f or theta transpose, you multiply and you will get this value. So this is a supervised learning. Okay. The unsupervised learning, the simplest example is this. That is the data, and we do not have any kind of labels. Okay. But we by visualizing, we know that this data having a two clusters. So by do not knowing the labels, but if you want to do some processing and you just identify these two clusters, there's an unsupervised learning. So basically by looking at the features, we group the features together. Okay, so learning about the features, that's unsupervised learning. So this is the two main part. Then there is the called self-supervised learning, semi-supervised learning. There are so many things, reinforcement learning, so many things are developed in the machine learning domain, but you can explore it. But at the end, once you have a model, so what are the other requirement of the machine learning libraries? That once you have trained the model, you need to evaluate that model. So model evaluation is also an important part, which you can do using the sklearn library itself. So just see a little bit about the sklearn library. So here is a linear regression problem. So I just as given you as example, linear regression is what? It's a theta transpose x problem. Given a x, you want to estimate the y. Okay, given x, you want to estimate the y. So so for that, let's say here I define the data a and b, and y is equal to 2a plus 5b plus 3. So we know the function f. Okay, but let's say unknown, we do not have. So we created this data, thousand data, and we created data set. So now the d is a 1,000 data set. So now we perform all the operations and we try to estimate this function 2a 5b plus 3. So this is the data frame, this is the data. So we have a whole data. By looking at the 5 data, we can see. When we do pair plot, we didn't get the idea, okay, these features are varying in such a way. So we see here, let's say see A, B, and C. So you can see the 3 data frame A, B, and Y. So we see that A and B are independent, but Y depends on A and B. So you see here A, B, and is okay. They are just kind of random, but Y is independent. Y is varying with the B also. Y is varying with the A also. But if you see the A and B correlation, it's kind of random. There is no any sense. But Y and Y varying with the B and Y varying with the A, you can see directly. So you get the idea. Okay, Y depends on A and B. Same way. So once you do this, you can simply divide the data. So mostly in the machine learning process, we divide the data instead of two things: train and test. Why? Because You doing the operation to you learn the parameters using the known data set. But when you are going to use that, let's say you take the data set from the past. Let's say you do. I'm just taking the example of the IoT. IoT sensors data set available for the 1,000 days. From that, you want to use that application for a future prediction. So you have previous data, but the new data set is not available with you. So if you want to work over it, from the 1,000 days, you use the 600 data for a training purpose and for testing. So you know, okay, we are going in the right direction. So that is done in a this. So here you simply have to define the model. You can fit linear regression and it gives the intercept. So you see here the coefficient 2 and 5, exactly you able to find out the coefficient which is there is 2 and 5 linear regression by doing the fitting the linear regression model. Okay. Same way, logistic regression, linear regression, both are supervised. In a logistic regression, we have a so in a linear regression, theta transformation. In logistic regression, we have a classification. So this is a problem of prediction. You predicting the value like a house price prediction. Here you let's say you want to classify uh, cat and dog classification. So here is a data set for the iris flower data set, and different features are there. And from that, you want to define the species, so you can do the classification using logistic regression. I'm not going into depth. If you are interested, you can ask the question and we can go further in depth. So this is about the applying the machine learning libraries for doing the machine learning. But what your model will give you, what's its result outcome? You want to evaluate, then you can use the evaluation like as classification report and all is also available inside the. This is an example of the k-means unsupervised learning. So clustering also you able to do. So here you can see 1, 2, 3, 4, 5, 6. I created deliberately 2 clusters and 3 clusters. So one is above 20, one is near to 50, another is a 1 to 6. And when do other clustering, automatically data is separated into it. So this is about the basic sklearn library, but sklearn library is also limited to machine learning application, not the deep learning application. Deep learning like multi-layer perceptrons and all. So if you want to go to multi-layer perceptron, there are the TensorFlow, PyTorch, Caffe. These are the libraries which we use. So I will just introduce the one of the. This is a TensorFlow library from the Google. So TensorFlow is a popular library, and what I explained for the GPU is comes here. So TensorFlow library have a capability to use the GPU for a processing. So basically, what is do is use the tensor data structure, which basically define the whole data set in terms of the graph. So computer science perspectively, it's a graph. Once the graph is defined, it performs the operation over the graph. That graph's age define the operations and age nodes define the inputs values. So you use the TensorFlow and you can do all the operation of machine learning, or you can also do the operations like deep neural networks also. So here I'm defining 5 plus 3, 2 constant. You can do some constant operator. Here TensorFlow is there. So now MNIST is a huge data set of the handwritten data set. I am just giving the small example and then we conclude. I think if you are interested, if you have questions, we can have one discussion. If you do not, then I just go to it. So MNIST data set is there. You MNIST data set, handwritten data set. I am showing here one example. And then training part, you define the architecture. So here automatically you can define the architecture. When you first data set, you do the 78 process, you simply first layer, second layer, and then drop out, then whatever architecture you want to define, you can define the deep architecture in model. You can simply fit. After training, it's giving you a training accuracy of 97. Now you want to check that it is how it predict. You can do the predict. You can use the prediction. Based on this, you can verify the different data sets. So phi is 1. So you can see that it is rightly predict this phi. So TensorFlow is a very huge library. So many functions are there. All the deep learning applications are there. And same way you can do this for so many other algorithms and all. So this is thank you for listening. So actually I what I given you, so for starting from the Python basics to the deep learning library. So what are the steps of the performing machine learning or deep learning in any sort of research problem? So first thing is you need to use the data you want to data input. So that you can do using a NumPy library. So for that you need a Python basic. So that is there. After you know the NumPy, everything is number. You want to do with the tabulation or all, you can go the data frame is all in the Panda libraries. You do the data processing and all. Once you do the data processing and things, and then you can always go ahead with the data cleaning process using some functions, and then data visualization using the Seaborn library kind of thing or a Matplotlib kind of library thing. Once you do that, that's called EDA. You can apply the machine learning if you want sklearn. If you want to apply the deep learning, you can use the TensorFlow. Once you do that, you can evaluate that using sklearn toolboxes or the TensorFlow tools, and then you can perform it. So yes, I conclude here. These are the like things. I feel because you do not have any questions, I feel that these are I think some of the basics. So maybe not have a question. But still, if you want to have a questions beyond this and or other research problem questions, let's say how to use a machine learning and deep learning, you can ask me. Yeah, I'm concluding here.
Okay, sir. Have you any queries? Have you any queries? Please ask your question.
It is not limited to the Python part, but if you can. My expertise is in a deep learning and how to use the deep learning in a different domain. I already use deep learning for deep learning and machine learning for my hyperspectral remote sensing area. Also, computer vision. I'm using. I'm also using for wireless communication. I have a bit of understanding about the embedded systems and IoT also. Yeah.
Have you any queries? If you have any, then we should conclude this session.
Yeah, I strongly suggest maybe you know the Python or maybe you know the machine learning libraries, but I strongly suggest that Python notebook which I shared with you, you just go through it for it's a hardly require 20 minutes, but go through it because I actually formulated that in a series of steps which are required in machine learning. So it's always clear your flow on working on a machine learning applications. Okay, thank you very much for inviting me. Thank you.
Thank you, sir. My sincere thanks for your presentation, sir. Your insights and expertise made a significant impact, and we are grateful for your valuable speech. Thank you again, sir, for you sharing your knowledge.
Okay,
Thank you,
thank
sir.
you for
Thank you.
inviting. Okay.
Thank you. Thank you all. We will meet again tomorrow, 10:30 a.m. Thank you.